Hi everyone, I continue making Dune Buggy from GTA 5. In the last series I welded the frame, in this one I'll work on the suspension. Fortunately a service kit for this type of car is still available nowadays, so I completely replaced all the rubbers since the old ones got completely defective with age. I also checked the brake pads and the wear on the hub bearing. They seem to be changed at the proper time and there is no wear on them. Torsion bars, which are located inside the beam pipes and act as springs, also turned out to be intact and covered with oil. Now I'm gonna weld the front beam into the front part of the frame. The frame tubes are slightly adjacent to the dust caps of the levers. We need to bend them at 10 or 12 millimeters inside the frame. Also, if we put the steering gear assembly the way it stands on the car, it'll be beyond the frame. Of course, in this position it'll stay operative, but I want to make an exact copy of the Dune Buggy from the game, so I'll use the steering rack. But this will be later. Now I'll bend the pipes by making a saw cut in the center of the frame. The beam was centered with a thread in cutting plane lines. After the beam is welded in place, we need to mount the wheels and check whether they touch the frame. The default front wheels will stay for now. They are practically suitable for the size of the game model. Most likely, the front part of the buggy will have to be loaded with something because of its underweight. I'm afraid the suspension won't work as expected. Now a bumper that is integrated into the frame can be welded to the beam. As I want to install the steering rack into this buggy, for the good of experiment I'm gonna swap the steering members in order to remove the steering arms back. Everything looks good so far. The picture will become clearer after the installation of the steering rack. That's what I was talking about earlier. All the spare parts fit perfectly and look like they were from the game. Further, according to plan goes the rear suspension. I tried the rear suspension arm on the frame. The strut turned out to be right under the amplified pipe. The arms will be attached to the frame through their standard brackets, but we need to add one more element to the frame. In my case, I'll use a metal angle. We can use a pipe instead of it and just weld the brackets to it. I drilled some holes in the angle for the bolts and the brackets. One more detail must be welded to the angle. I made it from the same angle. Now the entire construction can be tried on and afterward welded to the frame. I leaned the angle against the pipe and aligned the center points. Then I attached the angle to the frame on tack welds. The outer bracket hangs in the air. I decided to strengthen it with pipes. It turned out well. In this case, the angle will distribute the load from the rear arms. The suspension arms are in place, which means we can move on to the rear suspension struts. If the upper mount of the strut is welded under the reinforcement pipe, then the lower part will touch the gear drive shaft. And if there's some space, then the upper mount of the strut will be shifted back with no reinforcement. Of course, we can weld it as it is and probably nothing will get bent, but I want to make everything right and place the upper bracket of the strut under the stiffening rib. For this purpose I removed the lower mount of the strut for a couple of centimeters from the drive gear. After welding the mount, I made a slight reinforcement with the help of the slabs. The upper mount of the strut was made of a thick slab, in which I drilled a hole twice as large as the rod, as the rod will be moving during the work of the rear suspension. I welded a washer in the form of a cup to the slab. I also sawed it off from the donor. As a result, we've got some kind of hinge. I welded a pair of gussets to the upper mount for extra reinforcement and the back strut finally took its place. I also want to check the wheel toe. I'll make it using just a tape ruler. Good result. The wheels are parallel to each other. According to the project, the rear wheels should have 17-inch diameter. We fortunately managed to get those for a very good price. They are a bit worn out, but still so perfect for this project. This won't be noticeable in off-road conditions and with high tires. There is no point in making wheel spacers for standard hubs. It's easier to take the hub for 17-inch diameter discs or completely change the disc center by cutting it out on a laser beam machine. But since it's a budget project, I want to try to weld two discs together. One of the rear suspension arms will play the role of a bench. It's not possible to weld two discs closely, because we still need some space for tires. We have to move the disc away from the arm and weld it in this position. I'll weld a few sections of the shaped pipe into the gap between the discs. Now I'll try to center the 17-inch diameter disc. It is very difficult to center the disc by fastening it with welding along the way. I'll try another way. I drilled 4 holes in each disc opposite each other, then inserted the studs into the holes together with the nuts. Now we can center the discs relative to each other by rotating the nuts. The axial deflection displacement of the disc with a figure of 8 profile was removed by welding a couple of slabs between the discs. It's probably even possible to make the rim spokes from the studs and it'll work. After the discs became centered, I connected them to each other with a shaped pipe. If the disc was even initially, there'd be less wobble, but even so, it turned out to be a very good result. Now we need to make a banded steel wheel from this disc. I want to weld a metal strip about 10 centimeters wide. I think this will be enough. Two welded together pipes will help to bend the strip into a ring. The obtained ring should be attached to the disc only with tack welds for now. After the ring has been welded to the disc, we can weld the previously cut rim to it, also with tack welds, otherwise the disc will wobble. After welding, I treated the welding seam with a flat wheel. Now we can check it on the balancing machine. The numbers are kinda small. There is no sense in balancing the disc itself, as a large pre-used tire also has its own imbalance, so they're gonna balance each other. Sand paddle tires are very difficult to find, and I guess the needed radius does not even exist. Therefore I'll work with ordinary tires. I just have 2 sets of 17-inch diameter tires. First I'll try to put the smaller one. The space until the rim turned out to be about 10 centimeters, so there's nothing left to do but to explode it. I realized that this wasn't gonna work, so I did this deal differently. I put the bricks under the tire and pressed the disc with a jack screw, making the pipe to abut on the ceiling, thereby the distance from the rim till the tire got reduced. Success at first attempt. Now we're ready to balance the wheel. As I said, the disc and the tire counterbalanced each other's imbalance. It is still possible to optimize the imbalance by turning the tire about the disc and achieve even less numbers. The balancing adjustment ended well. The wheel can be pulled off from the machine and put on the buggy. Looks pretty good. We can also try and put some thicker rubber afterward. These hubs have enough safety margin, as they have those tapered roller bearings installed in them. The backside of the buggy is badly upturned, but after the engine is installed, the rear suspension will get a load on and the backside will suitably go down. Basically, the car platform is ready. Now we can put on the rest of the spare parts, and that's what I'll start doing right in the next episode. In the meantime, thanks to all of you for your attention. If you liked the video, put your thumb up and share it with your friends. See you in the next part.